Hello and welcome to the Senior Design final demo of the controllable active search trash collection robot for all your trash collection problems. Has this ever happened to you? You have so much trash in your living room that you can't pick up? Well, it sure has for us. So that's why we invented our trash collection robot to solve the problem. So first is the optical subsystem overview. So we 3D printed a camera holder with a 600 long pass filter, and also are in the process of 3D printing our laser mount with two lenses to do the 60 degree, or actually 50 degree IR laser divergence for our flashlight. This is us testing the Raspberry Pi camera laser pointer system. So as you can see on the left, it's modulating, and the raw system on the right is picking that up and returning the X position of the average between two laser dots to our camera system. So here we're showing the display image with what the Raspberry is processing, and the raw image, what the camera sees on the left and right here. They're running at way slower frame rate than what our laser remote is actually doing. But that's our camera system plugged into the Raspberry. We actually finished developing this, and it now centers onto the object, like so. In its environment, it isn't seeing anything right now, but when you move it over to the object that you want to select, it centers itself. So next we're going to show the drivetrain, which is fully functional. Our team member Adam has been working diligently with his stepfather, who does construction and like metal work. So he designed the entire holder for this system.
It needs to go back a little.
But clearly he still needs to work on the aluminum cups at the end of the arms, which, as we show later, actually deformed as we're picking up the 2-pound object. But this is us testing the initial servo scoop for our robot and actually getting it to work. We had a malfunction initially that caused the arms to both collide into each other and lurch forward into our electronics, which thankfully didn't cause much because it was just the regulators. But as you see here in the product requirements, the system must be able to pick up trash within a certified time, a specific weight, and the modulation of the frame rate of the camera versus the optic system. So there's our first test of picking up the object. Yet again, here's another trial we ran of picking up the object with our drivetrain in the specified number of seconds. This is, again, 4 times slower than what we actually expect it to be for the final. or we might have to adjust the specification according to what is acceptable for the overall speed for the drivetrain. I think our group members were just a tad nervous because we've been working on making this this build for quite a bit of time now to run it at full speed, but we did as much testing as we could. So see here, it's still kind of moving a bit slow. Like our average for this 5 foot was like, what, 90 seconds? We later ran it again with the dipsticks for the robot, and that actually increased our speed like 4-fold. But we really just didn't want to test it because like we didn't want anything to go wrong for this demo. As you can see, it does do a pretty good job of moving a specified distance. And there you go. Again, just to emphasize that this is quite the process. It picks up the water bottle. Perfectly drops it into the trash can. So the second thing we needed to check was the camera program running with the frame refresh rate of 50 frames per second. So the refresh rate was 50 hertz, as Kobe is showing here. But I actually believe that this refresh rate is actually the half the frame rate. So it's actually running at what I believe it should be 50 frames per second or 50 hertz. So Kobe did the average of this, which was 50.9 with standard deviation, or 50.2 with a standard deviation of 0.35. So for the last part, we did the robot must be able to pick up objects of up to 2 pounds. So again, we're taking the robot, and we actually got a peanut butter jar, which was about 2 pounds. Okay. And we had it go over and pick up the peanut butter jar.
Come on.
And as you can see at the end here, it weighs 900 grams or about 2 pounds.
Oh, yes.
I'm counting that.